In this video, I'm going to show you how multi-level feedback scheduling algorithm works, and for this particular example, I'm using three queues. Where this will be the queues Q1, Q2, and Q3. Where Q1 has a time quantum of 10, Q2 has a time quantum of 20, and Q3 will work on first come first serve basis. So here I have the set of data. I have four processors, process P1, P2, P3, and P4, and these will be the arrival times at the CPU and the burst times. Right, so let's get started with process P1. So process P1 arrives at the CPU at time 0. So at time 0 I have process P1 at the queue, and till time 8 I have nothing but process P1 will be running on the CPU, and by time 8 I'd have process P2 coming to the CPU. So until time 8 I have process P1 running in the CPU, and this one will be running for 8 time units. Since time quantum is 10, the process can continue. So, but for now I will mark the remaining time as 4, because this has a burst time of 12, and it only ran for 8 time units, so another 4 time units required. So by time 8 process P2 comes to the queue, so I'll add to the end of the queue, and process P1 will continue to work for another 2 time units till this time quantum for Q1 will expire. So until 10 process P1 will be running, and by 10 process P1 will expire, and it needs another 2 time units to complete. So I have to move, since the time quantum expires on Q1, I have to move process P1 from Q1 to Q2, and I'll add P2 to the front of the queue. I'll add P2 here. Right, so by the time 10 I have process P1 with another 2 time units required, and process P2 at the front of the Q1. So by time 21, if you see the arrival times, you can see that there's process P3 coming. So let's process P3 coming, and process P2 has a burst time of 25, so which means that this process can utilize the full time quantum on Q1. So let's consider time 20. By time 20 process P2 will be running, and this will be running for 10 time units, so which means another 15 time units are required to complete. By time 20 there are no newcomers, so by time 21 still P2 will be running. By time 20 P2 expires because it used the full time quantum, so I have to move P2 from Q1 to Q2. So I'll copy this one here and make this empty. By time 21 you can see process P3 comes to the CPU. So till time 21 it's process P1 who is running in the CPU, so I'll add process P1 here, and process P1 will be running for another 1 time quantum, because here 21 plus minus 20 is 1 time unit, so I need another, I'll reduce 1 time unit from the required burst time. Right, by time 21 I process P3 will come into the queue, so I will mark process P3 here. Right, so this one has the highest priority, so process P3, it has a burst time of 33, and it will be arrive on time 21. So this one will be occupying a full time quantum on process Q1. So process from time 21 to 31, process P3 will be running on the CPU, and this will, by time 21 process P3 will expire because it utilized the full time quantum, so I have to move process P3. Before that I have to consider time 30, because by time 30 P4 comes into the CPU, so I'll rename this as time 30, and by time 30 P3 is still running. This only ran for 9 time units, which means 33 minus 9 is 24 time units, and by time 30 process P4 comes into the CPU. Right. This only ran for 9 time units, so I can still utilize 1 time quantum in the Q1. So till time 31 process P3 will be running again, and since this utilized 1 time quantum, I have the time quantum will expire, so I have to move process P3 from this queue to Q2, and I'll bring process P4 up front. So I'll delete this one, and I have to mark the execution time of modify this by reducing 1, which means 23. Right, so by time 33 I have process P4 in the Q1, process P1, P2 and P3 in the Q2, and by time by time 31 all the processes have arrived to the CPU. So again Q1 has the highest priority, so I have to execute Q1 again, process whichever the process is in the Q1 again, so I have to execute Q1, and process P4 has a burst time of 2, so up from Q31 to 33 process P4 will be running, and process P4 will be completed, and I have to mark this one as 0 because process P3 completed totally. Right, next process P1 is in the front of the Q2. It only has needs another 1 time unit to complete, so I will execute process P1, and from 33 to 34 process P1 will run, and it will be completed, so I have to mark remaining time as 0. So since P1 is completed, I can remove P1 from Q2, and I can bring process P2 and P3 to the front of the queue. I'll delete this one. Right, by time 34 I have processes P3 and P2 in the Q2, and if I check the remaining time of P2, it has a time, it needs another additional 15 time units. The time quantum for Q2 is 20, which means that I can utilize, I mean, in one cycle, like in this one execution cycle, I can finish P2. So from time 34 to 34 plus 15 is 49. I can execute process P2 in the CPU, and which means that by the end of that time process P2 will be finished, so I can mark remaining time as 0. I can remove P2 from the Q2, and I can bring process Q3 to the front of the queue. Right, process P3 needs 23 time units, but the time quantum for Q2 is only 20, so I will execute this process P3 in Q2 for 20 time units, so which means 49 plus 20 means 69 time units, time 69. So till time 69 process P3 will be again running in the CPU, and by the time 69 the time quantum will be expired for P3 in Q2, so I have to move Q3 from here to here, Q3, and have to mark the remaining time as 3. Right, so this third queue, Q3, it will work on first come first serve basis, so whatever the process that comes here first will be executed first, and P3 only needs time quantum, only needs another 3 time units, so P3 will be executing till timeline is 72, and this will be P3 running again, and I can remove P3 from the queue, and the remaining time is 0. So this will be the process lineup. So if I remove this adjacent process lines, I can mark the total process as P1, then again P2, sorry, P1, P2, and P1 again, and P3 again, and P4 again, P1, P2 and P3. Hope this explained you how multi-level feedback scheduling algorithm works. Thank you.